today we will read the rules of inferences. What are the rules of inferences? We have read the laws of logic. We have seen that how the validity of one argument is checked by using the laws of logic and the propositional equivalence. Now, we will see that to check the validity of arguments, when more than one laws of logics are used, then whether we can combine together and to frame a new rule which is more compact or very easy to use for the validity. So, we can define that in laws of inference is nothing but the compact form of laws of logics. And we can define this compact form so that it is much easier to apply on the compound propositions to simplify or to validity of the arguments. So, in turn that will be much easier when we will apply the logic to prove some theorems. Okay. So, we take first one example. We take one example. Say we have propositions, primitive propositions P, Q, R, the primitive propositions. And we have two compound propositions. Let capital P is P only and compound proposition Q is P implies Q. Then we want to check the validity, check the validity of the argument the P and P implies Q implies Q or not. So, we can do in two ways. One method is by using the truth table. The truth table will check whether it is a tautology or not. Second method, we can apply by applying the laws of logic. More than one. And we can say that whether this implication is true or not, or this LHs that the left hand side I can tell that compound proposition simplified to Q or not, to Q or not. So, these are the two ways we can tell that whether this it is valid or not, whether it is valid or not. Okay. So, we see by the first method that by truth table. So, our example is continued is P and P implies Q implies Q, whether it is a tautology or not. We draw truth table. Here only there are two primitive statements. So, we give P Q. We require P implies Q and P conjunction with P implies Q, then P conjunction P implies Q implies small q. We take the truth values of P and Q, T T, T F, F T and F F. Then P implies Q, P implies Q is it is T T. So, it is T, other than this is only false, these are all true. Now, P and P implies Q. So, T and T, this is T, T and F. So, this is F, F and T, this is F, F and T, this is F. Now, if I tell this is my, say it is something called a compound proposition A. That means, this gives whether A implies Q or not. So, I will check A, I will check A and I will check Q. Okay. A and Q. So, this implies Q. So, T, T. So, it will give me the true value. Then F, F true, F all are F. So, these are all vacuously true. Once that P implies Q, P is true, A implies Q, A is false, then it is actually by default that implication is true. So, what we see that this is a tautology. This is a tautology. What are the second method? Quickly we can do, because it is much easier than truth table, because we have to apply the laws of logic. So, laws of logic, we can apply P and P implied Q. This is equivalent to P, and since now we know that P implies Q is negation P or Q. Now, we apply the associative rule, P and negation P or Q. P and negation P is F or Q. So, which is Q only, which is Q only. So, here also we see that this is, it implies That means, my compound proposition on left hand side is actually simplified to q. So, it is a valid argument. Now, see here we have applied 3 laws of logic. One is my equivalence, that equivalence of implication, this is one equivalence of implication. One is the associative, so this is equivalence. Equivalence of implication, it is associative, and this is our absorption, F or Q is Q only. So, these 3 together we can tell that this is, the name is that the modus ponens. This is the rule of inference is called the, it is called the modus ponens. So, instead of applying separately the equivalence, associative law, the absorption, together we made one laws of inference. So, now onwards, instead of applying separately this thing, we will be using the modus ponens. Next we see another example. Now, we take the compound proposition that negation q and p implies q implies negation p. As usual, p q are primitive statements. Now, we see that truth table, again if we write p q, then I need negation q. So, I write that I need p implies q, I write I need negation q and p implies q, I write. Then together the final implication, the negation q and p implies q implies negation p. Okay. I need a negation p also. Okay, directly I can write from here. So, I give T, F, F, T and F F. Now, negation q. So, this will be F, T, F, T. P implies q, T, 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 F, T, T. Negation q and p implies q. So, F, F, F only, this one will be T. Now, this implies negation p. So, negation p is T. So, negation p is F. So, F F it is T. Again F. So, all 3 F's directly I can write vacuously true, directly I can write true. This p, so this negation p will be here, the negation p is true. So, T and T, this will be true. So, again we get that this is a tautology. This is a tautology. So, this rule we tell that modus tollens and using logic we can directly prove that thing. Quickly we do. This is P implies Q. So, this is equivalent to negation Q and negation P or Q. The negation Q or Q, this will be sorry, this is the AND, this is AND. So, I can give negation Q and Q, this can be commutative, or negation P, which is equivalent to F or negation P, which is equivalent to negation P. So, again that we can combine all these rules and we make its modus tollens. So, the combination of a propositional equivalence along with a set of laws of logic, we frame some laws of inference, that means which will be checking the validity of some implication or the whether the implication is a tautology or not. Now, we enlist these rules. How many such rules are there? So, we take the rules of inference. The related logical implication that we write here. And the name of rule, like the last two examples we have seen the modus tollens or modus ponens we have given. So, we give some numbering. The first one we have seen the P and P implies Q. This is the convention of writing that, therefore, the result is Q. The result is Q. And what is the logical implication? logical implication is the nothing but the compound proposition that implies the final result. So, it is the P and because I have two compound proposition, one is the simple one that small p only and P implies Q, that implies Q, and name of rule we have already seen, this is called the modus ponens. We have seen the second one, the negation Q and P implies Q, that results negation P. So, logical implication is negation Q and P implies Q, these results implies negation P. It is called the modus tollens. Now, we give the third rule as if P implies Q, this is one proposition, and Q implies R, another proposition, then therefore, P implies R. So, it tells P implies Q and Q implies R implies P implies R, and the name of rule is hypothetical syllogism. This is hypothetical syllogism. Now, the fourth rule tells the P or Q and negation P. P or Q and negation P, it gives therefore, it is Q only. So, we can write P or Q and P or Q and negation P implies Q, and this is the name is the rule of this rule is disjunctive syllogism. This is now we have some more rules. We just do that thing. Again, rule of logical implication which are related to the inferences. On the name of the rule. So, we have these are very simple, that if P, that means if P is true, then P or Q is true. So, logical implication is simply P implies P or Q, and the name is addition. Since the disjunction or is called the addition. Now, we know this, we apply the simplification. That means, if P and Q is true, then either P or Q, I write P, it can be Q also. So, I can write P and Q implies P. This is simplification. See, this rule is very important, because we have two primitive statements and that implies only one primitive statement. So, by when we will do the simplification, this rule is very important. This rule is very important. Then we have some conjunction, that if P and Q, therefore, P and Q. So, P and Q, this is obvious, this actually gives me P and Q. So, I should give this thing, because we know the substitution rule, that means small p q can be actually a compound proposition also. Okay. Okay. So, this is my conjunction. This rule is very important. This is called the resolution. So, to simplify the compound proposition, this rule is very important. This is some disjunction of P or Q and negation P or R, because it gives the result that Q or R. So, I take the primitive statement P in disjunction with another primitive statement Q and negation P and disjunction with another primitive statement R, then they are actually related, the other two Q and R, they are actually related with the logical connectives, the disjunction. So, the logical implication I can write P or Q and negation P or R, this implies Q or R, and this is called the resolution. This is called the resolution. So, these are the 8 rules of inferences. This is the rules of inferences. That we can apply directly when we will try to simplify the compound proposition, or we will see the examples later, that when we will try to prove some theorems, then instead of applying the simple laws of logic, that we can apply the these rules of inferences. But one thing, whenever we will be applying these rules of inferences, we have to mention that which rule we are using here, and that is much easier, because now, so we have to remember the name of the rules, and then whenever, say if we apply the some P or Q and negation P or Q is implies, say in if I give that P or Q and negation P or R. Say it is simplifying to some P or R, Q or R. This is Q or R. Then I have to mention that it is the application of, we are applying the resolution, we are applying resolution. So, here if we remember that this, if I think that this is small p, this is my q, then p implies q. So, this is my hypothesis, or we can tell premises, and this is conclusion. So, some hypotheses are given, and from this hypothesis what we can conclude, whether we get the conclusion, and by using what rule of inferences, that we have to mention as a reasons for simplification, like that. We have to write that these are the reasons for simplifications. When we will do the examples next day, then we can write properly, and we will see that how we can apply these rules of inferences, and what are the formal way of writing this hypothesis, conclusion, and then the simplification applying these rules of inferences.